So in this module, we're learning how to use subderivations to help us show different kinds of sentences. In the previous video, we talked about how to use subderivations to help us show a conditional. When we already have a conditional on a show line, then we would do a subderivation of the consequent so that we can then apply CD. In this video, we're going to talk about how to use subderivations to help us show conjunctions. So let's suppose you want to show a conjunction box and circle. How would you proceed prior to learning about subderivations, or just in general? Well, you'd get box, then you'd get circle, then you'd apply a join to put them together to build the conjunction, and then you'd apply DD. So the two sort of challenging steps are 1 and 2. How then do you get box and how do you get circle? Well, there are a couple of different ways you might do that. You might use elimination rules, or you might use introduction rules to build up box and circle. But now that we have subderivations, we have a third way of doing it. We could show the two conjuncts, or show one or the other of them, depending upon what the derivation requires. So let's go ahead and see what that looks like in a derivation. So here we have a derivation, an argument, and the conclusion of which is if not u, then not t, and p. So we bring in our premises and we note, oh, how fortunate, p, our premise is actually one of the two conjuncts. So we've already got one of the two conjuncts. Now we want to get the other one. We want to get this one. Yeah, we want to get if not u, then not t. How are we going to do that? We have p and we have if t then u. We can't really do anything with either of those. We can't do mp or mt with 3 because we don't have t or not u. P is just sitting there. Well, we do a subderivation. And what we want to do is we want to say show. What we want to end up with is that. Yeah, we want show if not u, then not t. And once we complete that, then we will put 4 and 2 together, and we will have our conclusion, and we'll be able to apply DD to line 6. Not minus 6. Good. So that's going to be the general structure of the derivation, the overall structure. But we want to get this. But now the point of here is we can say, oh, well, let's do this as a subderivation with a command. So we type show, C-O-N-J, for show conjunct. And the computer says, oh, well, look up on that show line. You have a conjunction, and it has two conjuncts. Which of them would you like to show? And, of course, we want to choose that one. So this shortcut command, as show cons does, writes in, when we enter this, then we're asked, okay, what formula do we want to go here? So it's nice because it writes, we don't have to copy and paste this. We don't have to use this palette, which we get by right-clicking. We don't have to use the keyboard shortcuts. We just say show conjunct and then pick whichever one we want to use. And when we're done with this subderivation, this will remind us of why we did the subderivation. Right? Remember, when we complete a subderivation, we want to immediately use the line that we just made available by canceling that show line. And this will remind us why we did this subderivation in the first place. It tells us, oh, look, that's a conjunct of what one of the conjuncts we're trying to show. Okay, so let's go ahead and make our assumption. We can, because we're trying to show a conditional, and so we can assume CD, which gives us not u. Now, not u we can put together with if t then u using mt. We can apply mt to the two of those, and we'll get not t. That is just the consequent of line 4, which is what we need for CD, so we can apply CD to line 6, and box and cancel line 6. We'll close this up because we can no longer rely on any reasoning that might rely on negation u, because we're not trying to show negation u then negation t anymore. But that's okay. Now we're going to use line 4. So we're going to go ahead and say 4 to a join, and we want this one. We want the one with the p on the right, because that's our conclusion, and we'll apply direct derivation to line 8, and we're done. So pretty straightforward. The main thing here is if you don't do a subderivation, you can't get from 3 to 4. Right? We just go from basically, we're getting from 3 to 4 in this little subderivation because we just make this assumption, and then using the assumption, we apply modus tollens to line 3, and that gets us to not t, which is what we need. But the problem is we don't have a rule that lets us go directly from 3 to 4, so we have to do the little subderivation to go from 3 to 4. So that's what this looks like. So let's go ahead and try another one. So here is our next argument. We will go ahead and say show the conclusion. Let's bring in our two premises. There is no premise 3. Okay, good. So here we have lines 2 and 3. We can do nothing with lines 2 and 3, no MP or MT, because we don't have any of the pieces or the negations of any of the pieces. We don't have the antecedents. We don't have the negations of the consequence. So MP and MT is not in the offing. So we need to get the conjuncts. And we want to get the conjuncts of that together make up line 1. We can't use any of our inference rules to get them right now, so we're going to have to start doing subderivations. So we'll go ahead and use our show conj strategy. Which one should we do? Well, we don't know, and we need to get both of them, so let's just choose the first one. Okay, so we want to show if negation u, then negation t. Well, we can make an assumption, assume CD, whenever we can assume CD we want to, so we're going to do it. And hey, look, this is just like in the previous derivation. We'll do MT with 3 and 5, and that will give us negation T, which is the consequent of line 4, so we can apply CD. Hooray. Now, I was saying you should always use a show line. As soon as you cancel a show line, you should use it. That's actually not quite true. You should always check to see, do I want to do anything with the show line once you've done it? In this case, the answer is actually no, I don't. Because negation u, then negation t, what I'm trying to get is this conjunction. What we're trying to get is this conjunction. And this is the left conjunct. Yes, it's this. But we also need to get the right conjunct. And so actually we need to do another subderivation first before we can use line 4. Once we get if y then z, then we'll put it together with if not u then not t, and we will have we'll put them together with a join to build the conjunct. So we're going to say show conj again, and this time we're going to choose if y then z because that's the one we haven't done yet. Okay, we'll go ahead and make our assumption, which we can make and which we want to make, assume CD, which gives us y. Now we want to see, can we use y? Well, not immediately, but for MT with line 2, the consequent is negation y. For MT, we need the negation of the consequent, which is negation y. And we can get negation y by applying dn to line 9. And now we can say 10 to MT, because 10 is the negation of the consequent of line 2, which gives us negation z. Can we box and cancel? Not quite yet. We want the consequent of line 8, which is z, whereas on 11 we have the double negation of z. So we're going to have to remove those double negations, which we can do with double negation elimination. That gives us z, and now we can apply CD to line 12, which will box and cancel line 8. Okay, we'll go ahead and close that up. And now we've completed another subderivation, so we want to check, can we do anything with this new line? And yes, we can. We can use 4 and 8 together to build line 1, which will then let us apply DD. So we're going to say 4, 8 adjoin. We want the negation u, then negation t on the left, so we're going to choose the first one. Okay, so 14 is the conclusion, and so we're going to say 14 DD. So there we go. We now use show conj twice. And remember in the previous video we saw that we can do multiple subderivations. In the previous video, the multiple with conditionals, the multiple subderivations happen to be inside of one another. That's not what happens in this case. Here we have one subderivation, and then we do completely separately a second subderivation. So when we're doing when we're trying to show a conjunction, we may have to do a subderivation first of one of the conjuncts, and then separately and entirely separately do a subderivation of the other conjunct. And we need to do them separately because they need to be on this conditional needs to be not inside any box, and this conditional needs to be not inside any box. If we did one inside the other, then when we were done with all of them, we'd only have one of these two. So we do first one, and then we do the other. We do them separately. So this, in somewhat more schematic forms, is what it looks like when we do a derivation of a conjunction. We say we're going to show box and circle, and then we immediately, well, we might bring in our premises, but then we do these two subderivations. First we do the subderivation of box, and then we do the subderivation of circle. And in fact, we even could use the premises just inside of those subderivations. We could immediately go to show conj for line 2 without bringing in the premises, and we bring in the premises inside of that first subderivation, and then we bring in the other premises inside of the second subderivation. When those two subderivations are completed, then we can build our conclusion with ADJ, as in this example we've done on line 10, and then we apply direct derivation to that, and our derivation is complete. So you don't always have to show box and then separately show circle. Maybe you'll have to do a subderivation of one or the other, or maybe you'll have to do a subderivation of neither. As you've seen for a while now, in many cases you didn't have to do a subderivation of either in all of the derivations where you've had to derive a conjunction, where so far where the thing you've had to show is a conjunction, you haven't had to do any subderivations. So you know you don't have to do show conj, but it will never lead you astray. If you went back to all those derivations that you've done in the past where the conclusion was a conjunction, you could have used this show conj strategy, and it would have worked. And then more generally, if you're trying to show a conjunction, it's never going to be a problem to say, let me show first the one conjunct using show, introducing that with show conj, and then to introduce the second after having completed that first subderivation, then do another subderivation of the other conjunct using show conj. Again, that will always work. It will never lead you astray. So if you want to show box and circle, show the conjunct circle and show the conjunct box, and using the show conj command, and then put them together with adj and then dd. And sometimes you will have to do this, as in the examples that we just looked at. So just to review this, if you want to show box and circle, you get box with assume cd. Then you would say show circle using show cons. You'd make an assumption if possible you might not be able to. You box and cancel show circle eventually, and then you immediately apply cd to circle, which will box and cancel show if box and circle. And you may have to do more subderivations inside of those, and of course you will be using your premises as well, and all of your inference rules. If you want to show box and circle, you show box with show conj. You make an assumption if possible. Eventually, using your inference rules, you will get to the point where you can box and cancel show box. You may need to do more subderivations inside of show box in more complicated derivations. Then, separately, having box and canceled show box, you will then show circle, make an assumption if possible. You proceed using your rules and so on, perhaps with other subderivations, perhaps not, to box and cancel show circle. Then you apply adj to put them together, and you apply dd to that conjunction, which will box and cancel your whole derivation. One last thing that we want to be careful about is the distinction between what do you do if you have a conjunction versus what do you do if you want to show a conjunction, or what do you do if you have a conditional versus what do you do if you want to show a conditional. So if you have a conjunction, say P and Q, then you just apply simplification, right? You break it up. But if you want to show a conjunction, then you get P and Q from elsewhere, and you apply ADJ to build P and Q, and you apply DD. And in particular, you might want to do subderivations of the conjuncts. So if you have the conjunction, just apply simplification. If you want to show the conjunction, then you get the pieces, perhaps using show conjunct. What about with conditionals? So if you have if P then Q, then you want to use either modus ponens using P, or modus tollens using negation Q. Right? You have the conditional, then you want to use it. How do you use it? You use your inference rules with it. What are the inference rules? MP and MT. And so you see, oh well, hopefully I have P or negation Q. If I don't have them, maybe I can get them. Yeah, that would be the approach. On the other hand, if you want to show a conditional, then you somehow or other get to Q, and then you apply CD. And one way to get to Q would be to do show cons. You don't always have to. In some cases you do. It will never hurt to do show Q. But again, if you have if P then Q, then you can use it with inference rules. If you want to show if P then Q, then you get the consequent and apply CD, and one way to get the consequent is to do show cons. So the strategies I've talked about are show cons and show conj. You use those with conditionals and conjuncts, but more specifically, you use them when you have a conditional or a conjunction that you're trying to show, not when you have the conditional or when you have the conjunct. If you have the conditional or you have the conjunct, you already know what to do. You just use your inference rules. It's when you're trying to show the conditional or you're trying to show the conjunction that we use these strategies that I've been talking about in this video and the previous one. So please, if you have any questions, let me know. Good luck with your homework.